Okay, looking at Unit 3, again, lesson number 1. The last example we finished was particularly this one right here. Now you'll notice with this one, again, example 5a, that I have two angles and a side. Okay, that's angle, angle, side. Okay, angle, angle, side. That's easy to evaluate. Okay, we find the missing angle and then use law of sines to find the rest of the sides. Okay. Well, in this video we're going to do 6, and this is the ambiguous case. If I'm given two sides and an angle, I have situations to worry about. Okay, again, two sides and an angle. Now, when working with the ambiguous case, you will every single time write the triangle in this following method. Okay? So, what I'm going to do is I'm going to zoom this out here, and I'm going to start drawing some triangles. Okay? Now, what we're going to do is we're always going to draw these triangles in the same way. Now, in case number 2, now yes, the notes are awkwardly backwards based on the textbook, and yes, I'm starting with case 2, not with case 1, but it is number 6AI. Again, 6A, okay, I. So, consider the case when one of the angles is obtuse, okay? And again, we're going to pick the angle A. I'm always going to draw every single triangle in this form. This angle is A. Okay, that means the side across from it is little a. Let me draw that appropriately. Okay. And what we're going to do is we're going to call this side over here C. Now, what I'm going to do with this is A, then B, then C, so this is little b over here. Angle A in I and double I, 6A, okay, are both obtuse. So I have A is obtuse. Now, this is not always true, okay, but if I'm given, again, if I'm given side, side, angle, side, side, angle, if I'm given that situation and the angle I'm given is obtuse, I'm going to draw this triangle where that angle A is sitting right here. Okay, and the other two sides are sitting appropriately. So, let's talk about the possibilities for the given values for A and C. Okay, let's assume I am given A, C, and A, C, and A, and I find that the little a is actually less than or equal to the C value. Okay, what does that mean? Well, let me actually draw that out again. This is in this situation right here. If I draw that triangle, I have an obtuse angle, something greater than 90 degrees. There's my A. Okay, I have this C value right here to here. It's that length. Now let's assume that my A value happens to be less than or equal to that value. Well, if it's less than or equal to that value, that means it's got to be that length that I'm given. Let me rotate that length around. Meaning that I want this length to reach that point right there. I want this length right here to reach that point. But if I draw this circle around appropriately, that's never going to reach. If this is A, and if it's anywhere in between there, less than or equal to that, there's not going to be a triangle. Okay? And this is why we call this the ambiguous case. There are chances that the triangle that I'm given is not a triangle at all, okay? And we have to account for that situation, okay? So, if I'm given A, little a, and C, and I find that the side across from the angle that I'm given, such that the angle I'm given is obtuse, okay, and A is less than or equal to C, if this is all true, then there's no triangle. Okay, let's look at the double I. Okay, now let's assume that we have the same stipulation. I am given some angle A, it is obtuse. Okay, I have this side C, and then I'm given my A value. Okay, and let's assume that my A is greater than C. Okay, so that means that it's not this length here, but it's something larger than it. Well, if it's anything larger than it, this is clearly something larger than it, okay? So that would work out. if that's A? What if it was this A value here? There's a triangle there. What if it was this A value here? There's a triangle there. What if it was this A value way over here? Is that still larger than C? Absolutely. Okay. With every single possible case of A being larger than C, there will definitely be one triangle. Okay, and this isn't a problem. This is actually good for us. Okay, I can solve this normally like I would with any other law of science problem. Okay, so this is the obtuse case. Assume I'm given a triangle with an obtuse angle A and two sides such that the two sides are next to it, one of them being the one opposite and then one of them being next to it. Okay, given that I'm either going to have no triangle or one triangle. No triangle for the case where the side opposite the angle is less than the other side. One triangle where the side opposite the angle is actually greater than. Okay, now that covers case 2. Let's talk about case 1. Now, case 1, there's a lot of information going on. Okay, let me write out all of that information very, very cleanly, very, very clearly. Okay. Let's assume, this is 6b, let's assume now that all the triangle I was given with, again, the side-side angle, where A is equal to the angle, okay, then let's also assume that A, that angle that I'm given, is acute. Okay, it's smaller than 90 degrees. If it's 90 degrees, it's going to be very, very clear that we're going to have a right triangle. Okay, there's only one right triangle. But if it's acute, there's a situation with this. So let's go ahead with that. Let's create an acute angle A. Okay, now mind you, I'm given A, C, and a little a up here. This side is not really determined. Okay, I need to hold on to the concept that this side, I have no idea what it's going to be. Okay, I'm going to call that B, and it's not determined because I'm given little a, little c, capital A. I'm given those three pieces in side-side angle. Now, it could be different values. Okay, it could be angle B. It could be angle C. But I'm just assuming it's angle A every single time. If it's not angle A every single time, no matter what I do, I'm writing my acute angle here if I have side-side angle, or my obtuse angle right here if it's side-side angle. Okay? Now, I'm going to drop a perpendicular down right there. Okay? Now, look very closely at this, and I'm going to call that line that I've dropped my height. Wait a second. That right there is a 90-degree triangle, isn't it? Okay. I can find the length of this height. Okay, given that I know that I have A, little c, okay, and I do have little a, but I'm not going to worry about that just yet. Okay, so what we're going to do here, okay, is we're going to go ahead and talk about the possible options for triangles again. Okay, let's start out with assuming, again, I'm going to hold off on identifying H, okay? I'm going to hold off on identifying H. Let's assume that I have, again, in the first case, A is greater than H, okay? If this length is larger than the height, okay? Looks like I've got a triangle here. I'm sorry, less than. A is less than. I apologize. Okay, let me redraw that triangle. Here, there's A. There's my height, and my A value is something less than the height. This can swing back and forth, but no matter what I do, that A value will never touch down here. And again, this angle is given, that's solid, and it's constant, and it's not changing. Again, if I look up here, I have side-side angle. This angle is not changing. This side is not changing, and this side is not changing. The only thing that can change is the angle up here, okay, and this length over here. But if I have a certain height here, and this thing keeps swinging back and forth, there's no way that it's going to touch anywhere. There is no triangle, okay? The second case, A is equal to H. So if my height, this height right here, is actually equal to that A value, what kind of triangle am I going to have here? Well, it's obviously going to be this right triangle, okay? It's going to be one right triangle. And again, the way this works out is the fact that I have this given to me, I have this given to me, I have this given to me, and this A value can be anywhere up this way and anywhere this way, but if it's equal to the height, okay, no matter what I do, it will always, 100% of the time, land on that line on the base somewhere, okay? Well, in this case, it's got to land at the 90-degree mark, okay? So if my A is equal to my height, then I'm going to have, okay, one right triangle. Well, what if I have my height is less than my A value is less than my C value? So my A value here, okay, if I draw that triangle one more time, let's go ahead and do that. There, there, there. There's my angle that I'm given. There's the C value. There's my A value, okay, and I'm going to put my height in here. Now, what I'm assuming is that my height is less than my A. So I'm going to have to extend this further. Let's also assume that my A is less than my C. So there's my C value. Let's assume that it lands something like this. Now, I'm going to do this very carefully. This length here, okay, the length of A, is smaller than the length of C. It can land over here, okay, or it can land here. There are two different possible situations for this triangle. Now, if this isn't clear enough, let me draw it a second time. Maybe it might help. Okay. I want to draw that there. There's my height here. I have the possibility of this thing landing somewhere in here. Okay, or somewhere over here. Now you'll notice the red on this triangle should make an isosceles with the base, and it does, because this length and this length are the same. But you got to keep in mind that there are two triangles here. There are the triangle that I have this one. I'm going to go ahead and zoom this back out and I'll draw it. Where I have this one, where that angle is still A, this side is still C, okay, and this thing is right here, A. But I also have this situation, again, that one right there is this one right here. Okay. I also have the situation where I have that and that don't change, A, C, okay. But now it's landing on the opposite side of the height. So it's over here. Okay. So now you'll notice that I actually have two different triangles. Transposing this one into this one would be about there. Okay, seeing that triangle there. So you'll notice with this, I actually have two different triangles. And unfortunately, with the ambiguous case, yes, I must, every single time, find all of the triangles. So if there are two, when I see this, I have to find them both. Okay. The last possible case, number 4, is A is greater than or equal to C. Okay. If A is greater than or equal to C, that means I'm going to have this situation here. There's my C, there's my angle A, and my A value is as long as possible. No matter what, it's not going to compare to the height. It's not going to compare to C, except for it's always going to be larger than it. There is, okay, one triangle. And it's very important that we understand that this one triangle, okay, is not right. It's not a right triangle. So I have all of these possible situations. If I'm given an acute angle A and two sides, okay, that match up with side-side angle, I have, if my opposite side is less than the height, no triangle. If the opposite side is equal to the height, I have a right triangle. If the opposite side is between the height and the other side, I have two triangles. I have to solve them both. And if I have my opposite side is greater than or equal to my other side, I will have one non-right triangle. If the angle is obtuse, okay, I have no triangle when I have A is less than C, and I have one triangle when A is greater than C. Okay, so you'll actually notice in both situations, A is greater than C, A is greater than C, I still have one triangle. Okay, we will actually look at the examples for this in the next